Hello everyone, I am Dr. Banala Sarita from Department of Electronics and Communication Engineering, BVRIT Nasapur. In this video, we are going to discuss the second unit, which is process of machine learning and evaluation algorithms. Of course, it is also models. So the machine learning refinery process and model evaluation is discussed in this slide. So there are various evaluation process such as data processing, model training and evaluation methods. So data processing mainly involves data cleaning and pre-processing, feature extraction and selection, and data transformation as well as the scaling. So these are useful while doing the data processing. Once the data is available, then the model will be trained by using this data. So the model training includes algorithm selection and tuning the hyperparameters and training and validation splits and also hyperparameter optimization. Whereas evaluation training is nothing but the test data. So here we use cross validation and performance metrics also we will consider and model comparison. This is a machine learning pipeline. So first we'll collect the data. We may create the data or we may collect the data. Once the data is available, data pre-processing will be done. Once the pre-processing is done, like normalization techniques, scaling, all the things comes under the pre-processing. Once the pre-processing is done, model will be trained by using the machine learning algorithms. And then we'll evaluate the performance by using various evaluation metrics. So understanding this exact sequence is the primary defense against the systems in data anomalies. Next, investigating the raw material. So there are two types of the data types like structured data and unstructured data. So structured data is highly organized and it is in the form of tabular form. So there is a relational between the parameters. And unstructured data set is there is no relation and it is not at all organized and it is not available in the table form, whereas it is free from the uh, chaotic text images and sensors. The first filter, data cleaning. So first once the data is available, we'll handle the missing values of the data by using the technique imputation, and then we'll remove the duplicates and then fixing the inconsistency in the data. And extraction and transformation is nothing but feature extraction. So there are various methods of feature extraction. By using the mathematical algorithms, we will extract the features from the data set. And once the features are available, we will transform the features such as scaling up and normalization are the feature transformation technique. And this is the feature correlation and redundancy. So this Venn graph indicates feature A and feature B, and the mixture of feature A and feature B is measures the relationship between the variables, high overlap and redundancy. So it measures the relation between all extracted variables and identify heavy correlation, and then it removes the redundant features. And feeding the training set into algorithms is mathematically lock-in patterns without memorizing the specific data points. So here the data set is indicated with the training set and testing set. Training set is used to train the algorithms and learn the hidden pattern, and testing set is used to help back entirely to verify the model's true predictions. And the total data will be divided into 80% of the training data and 20% of the testing data. And there are two severe mechanisms we can observe in the while training the data, that those are overfitting and underfitting. So first graph is indicating underfitting and the middle one is ideal fit and the last one is overfit. So underfitting is model is too simple to capture the underlying trend. So it gives a poor performance in case of the underfitting. An ideal fit captures the true patterns without memorizing any noise also. So it gives a strong performance in identifying the patterns. Whereas overfitting learns too much and it remembers the data. That means it memorizes the data and it is not able to generalize the unseen data and new data. So it gives the poor generalization performance. And there are two important parameters that affects underfitting as well as the overfitting. Those parameters are bias and variance. So bias is the error due to simplicity. So this majorly affects the underfitting. It causes the underfitting. Whereas due to complexity, overfitting will occur. So the variance is the parameter that affects the overfitting. As bias decreases and variance increases, we will find the underfitting, and as variance decreases and bias inherently rises, we will see the variance issue. And these are the evaluation metrics. So for any model, in order to evaluate the performance of the model, we need to consider few evaluation metrics. Basically we will consider true positives, false positives, also false negatives and true negatives. So from this confusion matrix or evaluation matrix, we are able to calculate precision, recall, F1 score and accuracy. So rigorous evaluation metrics are the final safety to check and ensure the model reliability in the evaluation metrics. Thank you.